Hey guys, good evening. I hope I'm pretty much audible as well as visible. Just a quick hi or hello in the chat, guys. If I'm audible, let me know that. So we are good to start. Okay, I think we are good to start. So today, guys, our agenda is prominently talking about the data visualization. So where we will try to introduce you towards the data visualization. So how data visualization is important, and in fact, in this, what all things are there, different types of graph. So what all do we do in data visualization? So what all different options do we have? So we'll talk about all of this, and that's pretty much what the agenda of today is, guys. And as always, it's pretty much a live session. So I will be happily taking up your questions. So if you have anything which you want to talk about, the profile, anything in general also, please feel free to reach out so we can talk about that. Hello, Shubham. Thank you for joining us. Cool. As I said, guys, it's pretty much a live session, so you can put up your questions in the chat and I'll try to answer that. So that's what we will be doing. But let's get started, guys. So today's session is towards data visualization, and we have to cover many topics. So let's get started. Just a minute. Okay, so now in the data visualization, we'll first introduce myself also. So, my name is Arpit Jain, lead data scientist myself. And the only reason I am here with you because I really like sharing my expertise, and data science is my true passion. And technically, I have around 10 plus years of industrial experience. And also, I'm a motivational speaker. So I do talk to students regarding the career, job placement. So anything in general also, if you want to talk about, please feel free to reach out. I'm definitely monitoring the chat, so we can take up your questions and try to answer it. Okay. So the next agenda for the day, data visualization. Okay. So as the name also suggests, data visualization. So what do you mean by that? Anyone wants to answer it? So I'm more than happy to take any answers here, guys. Data visualization. If you know anything about data visualization, or if you have used any tool, or if you have done anything in the past about data visualization, so please let me know. So I'm more than happy to know that. But just to tell you what is data visualization, like in terms of technical definition also, if I have to say, it's more like we are trying to see something visually. So my objective here is to see the details, whatever I have visually, right? So I do have certain data points. I say, suppose I have age, I have salary, I have name, and whatnot information available in my table. And I know that I have certain numbers or certain figures and certain names mentioned here. So these are what I'm seeing as a numbers right now. Right? Difficult to understand some sort of relationship, some sort of trends out of it. But again, same thing, suppose I say that I just plot this age with salary, something of this sort. So I have a graph which says that I have age here, I have salary here. And with this, I know that I could see some sort of trend. So basically, I'm seeing that, okay, as long as my age is increasing, my salary is also increasing. So the same information, the same values which I had here in terms of numbers got represented in terms of graph. So we have to understand one thing. So whenever we talk about visualization, we're talking about graphs. Okay. And in fact, for this, you do not, you're not expected to know something which is very fancy. In fact, if you are working with Excel, you are already doing the data visualization itself. So on Excel, you have an option to insert the graphs. You pretty much have already seen that, right? So in Excel, you can insert the multiple graphs, which could be scatter plot, line chart, bar plot. Not many different things are there in Excel itself, right? So those are also some sort of ways in which you are trying to analyze your data visually or pictorially, sometimes of visual appearances, right? That's pretty much what the data visualization technically means, guys. Okay. And obviously, in terms of data science, we have certain different mechanisms in which we try to do this data visualizations. So for example, I can do the data visualization on simple Python as well. So I have the coding platform Python. On Python also we have certain advanced libraries which we also will be seeing today, which can help you to do the data visualization very easily. That is technically possible again. Likewise, I can take help of certain advanced BI tools, and the name of them would be, say, Tableau. So Tableau is one tool, and we have Power BI as another tool. So these are certain BI tools, like the business intelligence tools, which is again helping you to do the data visualization job only with ease. Okay. So there's so many different ways in which we can do the data visualization, and every way and everything you have to understand. If I'm doing it with some other way, everything has its own pros and cons, which we'll be understanding with time. But the core agenda, the core objective of data visualization is I'm trying to see the information which I have, the data which I have, in a graphical format, in a pictorial format. That is pretty much what data visualization means. Okay. So just to quickly tell you what is data visualization. So the process of finding the trends and the correlations in our data by representing it pictorially is called data visualization. Again, it's more like a bookish definitions, guys. No need to remember this. Just to tell you. So basically the process of finding my trends. So when I say trends or any patterns or any correlations, that like the way I did it for age and the salary, right? So I'm trying to find the correlation and the trends and the relationship between these two figures, and that is what I understood from the data visualization, the graph which I just plot, right? So I understood that as long as my age is increasing, my definitely salary is also increasing. So that is pretty much what data visualization helps us to do. And there are certain various mechanisms. So Python is one of them. So to perform the data visualization in Python here, so we have certain advanced libraries, modules such as Matplotlib, Seaborn, Plotly. So all of these three are my individual different packages or the libraries, which are giving me certain functionalities or functions which will help us to draw or plot the graphs easily. Okay. So now what I'll do is I'll switch on to a notebook. So I've prepared a notebook in which I'll show you the different options, the different graphs which we could have, okay, in data visualization. So we'll run through that, and there'll be an easier way to understand the visualization part, guys. So meanwhile, any questions, please feel free to reach out. I'm just sharing my screen, and then we can pretty much do that. Just give me a minute. I'm just sharing my screen, guys. Just a minute. Okay. I hope my screen is pretty much visible to everybody. So now we will be actually running through the tutorial of Seaborn, and we will try to understand how exactly things could be done in Seaborn. Okay. So our objective is to understand in Seaborn what different things are there and what we could be doing on Seaborn. Okay. So technically here, if you can see here, Seaborn is nothing but a Python library providing the high level API for data visualization, okay, for Python programming. And the interesting thing to know is the Python programming here in Seaborn is basically an advancement on top of Matplotlib. So there are two libraries, guys, Matplotlib and Seaborn. So Matplotlib is, I would say, the base of every data science, visualization approach. And Seaborn is an advancement on top of Matplotlib, which is giving you some advanced features built on top of Matplotlib. Okay, so just a quick differentiation between these two. So Seaborn is an extension of Matplotlib, and Matplotlib is fairly good for easy work, while Seaborn makes it very simple to do the hard work also. And Seaborn is very well known to work with the pandas data frame. So in Python, we have again certain advanced libraries such as pandas and NumPy, which is used for data processing work. So those pandas and NumPy libraries, they work very easily with Seaborn library. So we're going to be using Seaborn with the pandas and the NumPy library as well. Okay, salient features, we have certain built-in themes, and then it's very good with the both univariate and the bivariate analysis. and it is useful for both regression and the time series data as well. So we will be, in fact, quickly seeing this, and we'll try to understand how this would help us. So just a minute. Okay, cool, fair enough. So quick installation. If you do not know how to install it, so we have pip install Seaborn. So pip is the functionality which is helping us to install the Seaborn. You can quickly do that. You can check the version like this, SNS underscore underscore version. So that is going to give you some the version details of it. And then interestingly, Seaborn comes preloaded with some data sets. Okay, so there are certain data sets which comes by default loaded up with Seaborn. So you can see this. We can use the function get dataset names, and it is going to show me the data sets which comes by default loaded up with Seaborn. So for example, here you can see anagrams, attention, car crashes, diamonds, exercise, flights, iris, MPG, Titanic, taxis, tips. These are very common data set which are very prominently used in any academic jobs, right? Any academic details, we are definitely doing that, right? So that is where I would say that it's very helpful that Seaborn by default comes loaded up with these default data sets. So it's always going to help you, right? So we are going to take leverage of this preloaded data sets, and we will be loading up this data sets only for a quick analysis. Okay, so let's get quickly started with the univariate analysis on Seaborn. So univariate analysis, as the name also suggests, single variable plot. So again, a single variable plot means in a data set we could have multiple different feature sets. So we are going to choose one single variable, and for that we are going to do some plotting on top of that. So for example, first is histogram. So histograms are my first plots in univariate analysis, which is nothing but it is the data distribution by forming the bins along the range of my data and then drawing bars to show the numbers of observation that fall in each bin. So for example, what does it mean? I have the column H, right? And I have a range which is starting from say 0 to 100, for example, right? And what I would do is, instead of taking this discrete values, I divide this into ranges, smaller bins. So smaller bins would be say 0 to 10 would be my first bin, 10 to 20, 20 to 30, 30 to 40, 40 to 50. So likewise, I divided the 100 ages 0 to 100 into 3 or 10 different groups, 10 different bins, right? And then I count the number of frequencies. So for example, I have say 1000 people, and out of 1000 maybe 100 falls in the range of 0 to 100, 0 to 10, and 20 falls in the range of 10 to 20. So likewise, for each of these ranges, I find the frequencies, the number of occurrences, and then for the number of occurrences, I plot the bar plot on top of that just to show the different availability of my data points here. So for example, and for this plotting the histogram, we have the function called as distplot. So distplot is a function which is helping us to plot the data set here. So what we're going to do is, since we have already installed Seaborn, so we are going to quickly run this. So we are going to run import Seaborn as SNS. So SNS is basically my alias to use Seaborn. And once I do that, what I'll do is I'll simply load the data set iris here. So iris, again, we're going to use a function load data set to load the pre-default data sets which comes with Python. So Seaborn here. So we're going to load up iris. So iris, the moment we're going to load up on DF, we're going to see it has 5 columns here. So 4 columns with the numbers sepal length, sepal width, petal length, petal width. And then at the end, I have species. So species basically certain flower species I have, and for each of these flowers, I have their respective dimensions, right? So I have a lot of information available here, and obviously I can run a lot of analysis also. So now quickly, what do you see here? The distplot. I can quickly run the distplot, and the moment distplot is run, it expects a argument here. So I'm going to pass, suppose, one of the feature sets, so sepal length here. So I'm going to use this sepal length, and I'm going to pass this under this plot. And the moment I'm passing this under this plot, you can see the graph is coming up here. Can you see this? So I have this graph which is showing me the trend of how the sepal length looks like in the different bin ranges. So on the bottom, you can see the ranges also 4, 5, 6, 7, 8, 9. So different bin ranges. And for that, I have the frequencies of my observations also coming up. Okay. That's pretty much what do we have. And likewise, I can keep on doing for multiple different things. I can do for petal length. And obviously, each of these functions, guys, accepts multiple different arguments. For example, when I say arguments, here you can see hist is equal to true, KDE is equal to true. So likewise, for every single function, there will be few set of arguments. So technically, you are not supposed to remember all this. So don't think that you are supposed to remember all these functions. No, not required. But yes, logically, you should be understanding it. So what does it mean? So for example, here when I say hist is equal to true, that means I'm talking about the bar, the rectangular bars which are there. And when I say KDE here, it is the run line which is going through. So likewise, if I put false true, accordingly, the data would be changing up. So that is where I have my univariate analysis. So distribution plot, the dist plot is very important here. So it is giving me the distribution, like how the data points are basically varying. So this graph here, sepal length, I could see that it is very much normally distributed. So I'm getting a sense of a bell curve here, right? A kind of a bell curve, which is demonstrating how the values are ranging. But here I could see some peaks and the lows, multiple peaks, multiple lows. It is not following a normal distribution here. So from each of these graph, I have to practically get to know that what does it mean, right? So how exactly we can use this. And then we talk about the bivariate analysis, guys. So bivariate analysis is basically where I talk about two variable plots. Two variable means now I have to pass both x and the y's. If you would have realized in the previous example, what we did, we just passed one feature set, either petal length, sepal length, petal width, and I'm going to see a trend of one of the feature sets, right? That's what we did. But now in this problem statements, what is my objective is I'm trying to understand how we can do the things for bivariate now. So I would be having both x and the y's, and I'm trying to understand how x and y's are changing here. Okay, based on each x and the y's, how my different graph would be changing. So for this part here, if you could see, what I'm doing is, in the bivariate analysis, the very first is my joint plot. Okay, so joint plot, what it does, it basically gives you an option to pass both x and the y's. And can you see this? The moment I'm passing joint plot, x is my petal length and y is my petal width. So I have both x and the y's, and I'm seeing a trend here in the bottom for the y and the x axis. So there are two parts for this graph, guys. What you have to understand here. So joint plot is a very fancy graph. What it does, in the center, the rectangle, the square box which you could see in the center, it is giving you by default a scatter plot. So the points through which I'm able to find the relationship. And on the right side, the boundaries, you are seeing the bar graph also, the right side and the top also. So basically that is nothing but it is showing you the univariate histogram for individual feature sets. So your y-axis is petal width, right? So y-axis is petal width here. And this petal width trend is basically coming here on the right side. Okay, so petal width is what I'm going to show here. But on the bottom, you can see petal length. So petal length is what I'm trying to look at here. So from the x-axis, and this trend of petal length is coming on the top. So that's pretty much how things are being defined in joint plot. So you get the benefit of both the bivariate analysis, basically as a scatter plot. I'm trying to see the x and the y relationships. And also on the sides, we are able to get the univariate analysis as well in terms of histograms. So that's the benefit of joint plot. There are certain variations here. There's an argument called as kind. I can change the kind of it. The moment I put hex, you can see in the between, the same scatter plot is now represented using hexabins, right? So another fancy method of representing the same trend, I can use hexabins order. So hexabins, again, it is color encoded. So dark values where I have the higher concentration. So that's pretty much what it means. And I can also use KDE. That means where I'm using the density estimation to show the graph. So that is also possible. The next is in the bivariate analysis is my Relplot. So Relplot again is basically a simple x and the y plot in which I can specify the kinds which I want to use. So by default is again a scatter plot, but I can also put line to show the line plot as well. Okay. So now in this case, I'm loading up the data set tips. So tips here, you can see I have the total bill, tip, sex, smoker, day, time, size. So basically a detail of a data set where I'm saying at what time, what person went for dining out, whether it was a dinner, whether it was lunch, how many people were there at the time of dine out, male, female, who paid the bill. So all of those details pretty much present here in this tips data set. Very good data set. Now, in the bivariate analysis, I'm trying to analyze the relationship between my two different variables. So for example, the first, I want to analyze how my total bills are changing with respect to tips. So how the tip values is changing with respect to my total bills here. So we have just plotted the scatter plot here. So we have the X and the Y axis. So X is my total bill and Y is my tips here. And you can see kind is equal to scatter. And I'm passing the data is equal to tips. So data is tips data. Can you see this? The scatter plot which is coming up here, I have the total bill on the bottom and the tips on the left, and you are able to see kind of a linear relationship, not that strong, but definitely a linear trend. So as long as my total bills are increasing, my expectedly tips are also increasing, right? And I could see some very strong potential outliers towards the top end. So very, very high tip values, $10 for $50 of total bill, right? And then I'm seeing very low tips also, like this point. So for a bill amount of $32 or $33, I'm seeing a tip of $1 only. So on either sides, I have certain outliers. So not a very strong linear relationship, but still the curve is towards that direction only. Likewise, I can put the kind as line also. So it'll give me the trend in terms of line graph. So on top of this, guys, additionally in Seaborn, I have a very strong argument called as Hue. So Hue is a very, very, very powerful argument in Seaborn, and it is almost omnipresent in all the different graphs here. And what it does, it adds you a third dimension to your data. So for example, now I'm anyway was seeing the relationship between my total bill and tips, but now I want to see the same relationship with respect to days, right? I want to see how this trend between total bill and tips changing with respect to days. So maybe Thursday will have more outliers, maybe Fridays will have more flat curve, maybe when Saturdays will have more steep curve, right? So I would need to see the trend day wise also. So for that, if I need to add a third dimension to my data, Hue is one of the very potential argument which adds the third dimension to my graph. So the moment I put Hue as day here, now you can see the data points are changing with respect to colors here, right? But unfortunately, if you see this graph, there are so many colors here. It is not that easy to make out trends here. Don't you agree, guys? Right? So I have the points here. It is very, very difficult to read the data points from this graph. So it will always advisable that now instead of using hue, I have another argument called as call. Okay. So hue and call, hue and the second is call are my two different arguments, which is adding the third dimension to my data, the graph. So hue, it is prominently doing the color encoding. Okay. And call is basically dividing the data sets into different graphs here. So for example, suppose I pass call as day here. So and hue as sex. I can probably pass both of them also, hue, sex, and call days. Now you can see this. So the day basically Thursday, Friday, Saturday, Sunday, this got split in 4 different graphs here, guys. 4 different graphs, right? So what I'm doing is, instead of calling it under one single graph with multiple colors, I split the graph into multiple different categories. That becomes more readable. And within all of these split graph, I can add the 4th dimension, maybe sex, like male, female also. So this hue and call are very strong arguments, which is helping us to basically, what to say, kind of giving us the 3rd and the 4th dimension to my graph. Okay, that's very strong argument. Call wraps, on the other hand, it is, suppose I have too many splits, so I can specify that how many graphs will be there in one single row. So I specified 2. So first, all the rows will have only 2 graphs at the max. So basically, just it's more like a resizing effect I have. So I can do all of this thing. It's completely fine. And you can see this on the Relplot. I can put kind is equal to line. So I'm seeing the relationship between my size and my tip. So and I could see, as long as my the family size is also increasing, my tips is also increasing. Can you see this? So on an average, the tip for the family size of 1 and 2, it is ranging between 2 to 2.5. That's pretty much what the maximum of my tips are. But as long as we're increasing the family size between 4 to 6, the tip size has increased drastically from 2 to 4, and is going maximum up to 5.5 and 6 also, right, on an average. So that's pretty much what we are able to analyze from this. So depending on the size, how my tips are changing. So likewise, there's so many different options. We have so many different what to say, options, and so many different relationships. So because we have different feature sets, right? So that always gives us an option to find out the relationship between my multiple different patterns. So it's not like people will come to you and say that please do this. So it's about you as an analyst, like what kind of relationship you want to analyze. Okay. The next is pair plot. So as you know, in the Relplot, we are passing one by one these all different categories, and we are trying to see the relationships. So in pair plot, what it does, it plots the graph for all the numerical data types by default. Suppose I have these data sets, so 5 columns here, iris. The moment I plot the pair plot for this data set, and I put Hue as species, so what it does, it is plotting all the possible combinations of relationships. Can you see this? It is making 4 cross 4, basically 16 graphs for each of these relationships. So sepal length with all of these, sepal width with all of these, petal length with all of these, and petal width with all of these. So basically 4 cross 4, 16 graphs will be made here. And then obviously all of them having their respective trends, so which needs respective analysis. That is definitely going to be there. But what we could understand is that is basically how the values are changing here, right? So we have to understand the relationship between each of these variables one by one. So pair plot is the advanced function, the function available in Seaborn, which is helping us to plot the entire set of combinations of graph in one single go. Okay, so we can use pair plot for that. But these are, if you realize, these are the graphs which is happening on numerical. So if you talk about the bivariate analysis, there are 3 different categories, guys. First, I talk about numerical to numerical. So both x and y's are numeric data. Second is numeric to categorical. So one variable is numeric, second is categorical. So in this case, I have again certain interesting plots coming up. So I talk about strip plot first for this. So what is a strip plot? Strip plot is one of the variable under which we have to be a category by default. Okay. Same data sets. So I have this sepal length, sepal width, petal length, and petal width. And now on top of this, I'm trying to plot a strip plot. And in this strip plot, I have x is equal to species and y is equal to petal length here. And I'm plotting the data here. Okay. So now can you see this? Based on each categories, I'm trying to see how the values of petal lengths are changing. So for Setosa, we are able to see that all the value points are ranging between 1 and 2. But for versicolor, it is ranging between 3 to 5.5, 3 to 5. And Virginica, it is ranging from 4.5 to 7. So obviously, there's a very clear distinction between the respective trends of my values for each of these species. And that is where strip plot comes into picture. So it gives you a clarity of thoughts where based on each of these categories, how the values will be changing for my data points. So strip plot is another very interesting plot. Where swarm plot is another alternative of strip plot. So the only difference with this is, now in the strip plot, you're seeing the multiple data points are getting overloaded, right? So overshadowed here. And obviously, likewise, the density of things would change. But in swarm plot, there will be a horizontal spread of data points. That means each and every single point will be plotted, and you will be able to count each of these points. Now, can you see this? So I could see I have a higher concentration of values of Setosa under this range, so I could not count the values in strip plot. But in swarm plot, can you see? I could see a belched out belly here, a belly here in the between, right? So I have many data points which is in the smaller range. So likewise, the values will spread out horizontally, and you can count each and every single points for swarm plot. That's the benefit of swarm plot, guys. But again, another alternative from same category of graph, categorical to numeric, in which one of the feature should be a category and another should be a numeric data set, right? Next category of graph is box plot, guys. So box plot is again very commonly used graph. Here it is also termed as box and whisker plot. So basically, if you see the graph, you will be seeing certain whiskers and then you have a box in between. So prominently, this box talks about three things. The upper value is the 75th percentile. The middle line, which you are seeing, the middle black line in the graph, which is pretty much median, 50th percentile, and the bottom line is nothing but called as 25th percentile of my quartile of my value. And this box is pretty much the range between 75th percentile and 25th percentile. We call this as interquartile range, also IQR, right? And based on this IQR, the upper whisker and the lower whisker gets decided. There's a formula for that. So lower whisker is nothing but 25th percentile minus 1.5 times of IQR, while the upper whisker is nothing but 75th percentile plus 1.5 times of IQR. And any data point which goes beyond this range, we generally term this as outliers. So box plot is very good to identify my outliers of my graph. So for example, you can see here, when I'm trying to do a box plot with x is equal to species and y is equal to petal length. So can you see this on versicolor? I have a point here towards the a farther end of my lower whisker. So I could fairly say that this point is definitely an outlier for my graph, right? So likewise, this box plot helps us to identify the outliers very distinctively. Okay, I can keep on plotting multiple things also. I can call the argument hue also as well here. So for now, the hue will add the color encoding of the category. So Thursday, Friday, Saturday, Sunday. Different two categories, male, females. I have the respective values here. So that is again totally possible. And then we talk about the next interesting graph is my violin plot, guys. So box plot. On top of box plot, another advancement of box plot is violin plot. So violin plot is nothing but, I would say, another type of box plot only with two more advanced things in this. So box plot here, you are not able to see the data distribution. Data distribution, by that I mean how strongly the data density, I have to say. So how strongly my value is concentrated on a smaller range. So the density information is not there, and also strength of outlier. So these two things, for example, in violin plot, can you see the same graph? Now violin plot, and have x as day, y is equal to total bill. And let's try to analyze this data here. You can see the fat belly in between the graph, right? So this area shows that more the belly, that means more concentration of my data in that region. That means it's more like telling me the density of my data points on what range I have. So that is where violin plot comes very handy. So it gives us the mechanism in which we can find out at which area, what is that range where I could find out where my values are more. So that is where violin plot comes into picture. And also second, you can see the peaks on the top. You can see a sharp peak here, right? But in the few areas, it is blunt peak, right? So more sharp and more farther, the farther the peak is, that means the strength of my outlier is very strong. That means I have a very strong outlier there, right? So that is how two advancements we have in terms of violin plot. So we talked about the density. So basically where the data points are strongly visible. And also I talk about the strength of my outlier in my violin plot, guys. The function is simple, violin plot. I'm going to call this over this, pass the data, and I'll get the output. Again, as I've said, I can pretty much add the hue column here. So hue is to add the third dimension to my data. I can also call another feature set. So hue is one of those which can be used here for my third dimension. So I'm passing for male, female, sex. So Thursday, Friday, Saturday, Sunday, I'm able to see that now it is color encoded. So for different males and females, and respectively, the value points are changing here. Right? So interestingly, if my hue, which I'm trying to add the third dimension as, I have other advancement on violin plot. If this hue has only two categories, if hue has only two class, We can combine these two graph also. So we can use the argument call as split. Split is equal to true. That means the left side and the right side of the split will be showing the trends of my two different graph here. Okay. So that is basically the left side is my one class male, right side of my belly is for female. So it's very easier to compare the densities of two different categories which I have. So that is again which can be done using while in plot here. So I can use the function the argument split is equal to true to showcase the values here. Any questions, guys? Meanwhile, so we have covered these many details so far. So we have been talking about how we can do things. So in terms of the data points, so we have been talking about numeric to numeric, different options are there. We talked about categorical to numeric, and then we in this categorical to numeric, we have been talking about box plot, violin plot, so many things are there. And then now moving ahead in terms of finding the statistical estimation of my seaborn, we again have certain good graphs, like for example bar plot. So bar plot is again another graph which is available in seaborn, helping us to take the central limit theorem. So basically what it does, it is finding the relationship between a categorical variable and a continuous variable. Let's try to understand that. So I'm using a data set Titanic. So in this I have all the data points available here. Now I'm using a bar plot. In this bar plot, I'm passing both x and the y's here. And for this x and the y's, I'm passing the hue as well. So hue is nothing but adding the third dimension to my data set. So for this x and the y, I'm able to see the trend of my data point. So basically, I'm seeing for males and females how the survival has happened. Can you see this? So for male and female, respectively, for the classes as well, I'm added the third dimension here. So how the survivals has happened. So I'm again another statistical estimation which I'm trying to see from the bar plot here. Another interesting plot available under Seaborn. I can keep on adding multiple arguments. So for any method, whatever you will be loading up here, you will be seeing multiple different arguments, guys. Just you can press a shift tab. For example, let me show you that. So I'm gonna import Seaborn as SNS here. And the moment you put say SNS dot bar plot, for example. Okay. If I press a shift tab, can you see the arguments here? So likewise, all of these different functions will have so many different arguments, obviously, and it is not expected from you to remember all these arguments, guys. Trust me, it is not expected. It's not mandatory, but you have to definitely understand like how the usages of these work. So with time, so you will understand that. But for that, you have the documentation as well. So you can pretty much read these documentation. It will give you the brief of how these different arguments work. But just to show purpose, I've tried to use different things also here. So I'm passing hue, data, palette for colors, ordering, male, female. I have the capital size, saturation is 1, error color is red, error width is 2, confidence interval is standard deviation. So I'm trying to add multiple different details of my graph here. That's pretty much what is happening here. Okay. Then I can use horizontal bar plot. So horizontal bar plot means I'm trying to just reverse the transpose the graph. So x will become y, y will become x, right? Now when you see this. So this horizontal bar plot looks something like this. So I have the x and the y. Similar thing, I've just transposed my graph. So even that is there. For that, we can use the function orient. So argument orient is equal to h. The function is still the same bar plot, but the orient now is h. Okay, so that's pretty much what we have. Then the next we have the count plot. So count plot is a special case where I'm trying to count each of my categories. So bar plot, it gives you a density estimation, but I'm talking about the count plot. So for each categories now, I want to only see the counts. So here I'm not going to pass the y variable. So y variable is by default a count. I'm only going to pass the category, which is class. And then here, it is going to give me the counts of it. So first class has approximately 200 records. Second class has approximately 190 records. Third class has approximately 500 records. So likewise, I'm able to see the number of records, the number of observations for my categories here. That's pretty much how the count plots are used for. And obviously we can add the count also a number on top of that. For that we have an argument called as bar label. So bar label, if I pass the containers, it is going to add the labels. For example, here it is difficult to read up the exact number. I can only estimate it, right? So by doing this, I can add the labels as well. So 216.184.491, I have the exact values also visually available. So I can do this using the hue variable argument as well. So third dimension to my graph, I can do that. So third dimension is my hue. So basically my man, women, and the child. So for that, I'm trying to put the counts, and I can do the, now in this case, I can run a loop for my bar label. And for each of my different categories, I have the values, the counts available for each of them. That is again totally possible here, guys. Next graph is point plot. So point plot is again a very interesting graph, which is used to show the point estimates and the confidence interval using scatter plot. So for example, here I have the two different classes, male, female, and then I'm trying to see the values, how it is changing when the class is changing. So for example, I see the survival rate. So based on my sex, male and female, how the survival has changed, and that is also respectively to each classes. So you can see for male, for third class, it was approximately 0.1, which is percent, and then now 0.1, it increases to 0.45 for females. Respectively, for first class, it was approximately 0.35 for first male, and goes up to approximately 0.95 for the females, right? So you can see that how the males and the females have their survival chances with respect to my classes. So point estimates is again one of the fancy graph which helps you to identify the point estimates of my survival. So I'm basically in different categories, how the values will change if my category is changing. So that is pretty much what point estimate talks about. Again, we can experiment a lot many things here. Okay, I think this is a similar thing. That's okay. That is also fine. That's okay. That's fine. I think then we can talk about, yeah, this is okay. So next is again in Seaborn, we also have certain very fancy part of doing the linear relationship. So we have been talking about linear regressions, right? So in Seaborn, we do have an option to directly plot the linear relationships. We have two functions for that: reg plot and lm plot. Okay, so reg plot and lm plot are basically the two things which is helping us to do the linear relationships. So only difference between them is lm plot gives you the plus extension of facet grid. Basically, I can add the arguments such as hue and call. I can do that in lm plot, but reg plot cannot have that. So you can see this. I'm passing the x and the y's here, and I'm getting the trend of my linear relationships. Okay. So likewise, I can, if I do the lm plot, the same x and the y's here, I can pass the call and the hue arguments for lm plot, so that I can split the graphs into multiple different parts here. So lm plot gives you that extension, which reg plot does not give. So a facet grid, so basically splitting the graph into multiple pieces, that can be done on lm plot. But again, the objective is to find the linear relationship between my different variables here. So x and the y's, based on that, I'm going to find the linear relationship. At last, guys, we have Heatmap. So Heatmap is basically a two-dimension graphical representation of data where the individual values are contained in a matrix format. So it is very important that we have a matrix format of data, and those values are going to be color represented. So for example, the flights data, I've just pivoted based on month, year, and passengers. So now you can see I have year, month, and respectively the passengers here, the number of passengers for that year and month. Okay. And the moment I call heat map on top of that, and if I pass on this data flights, which is pretty much this flights, and I do CMap, so whatever the color coding I want to do, now you can see this, the same data got now color represented, right? So where I could see that. So least is 200 with the red color. If you keep on going upwards, the color will keep on changing to blue. I can obviously change the color palette as well. But the core intent is, I'm with the help of heat map, I'm trying to convert the data from a matrix format, from a numerical format to color encoded. So I'm trying to see the data only with the help of colors. So colors is what heat map is used for. So we have direct function available. again the heat map where I can pass the matrix, the grid, it'll by default plot it. Cool, guys. So with this is what I wanted to cover technically. I wanted to show you how we can add up the details in terms of the different pointers here. So where I could have different graphs available, right? So this is pretty much important. So coming back to my slide, so this is what I wanted to show you. So here we have something called a Seaborn. So we talked about multiple graph options. So three things. First is numeric to numeric. Second is numeric to cat. And then third, we talked about cat alone. Right? So three things, that's pretty much what we were looking at in terms of graph, and Seaborn gives you all those different arguments. Always remember two arguments, which is very strong, hue and call. These are very strong arguments, which is giving you a third and fourth dimension to your graph. Okay, so these are very strong arguments. So always be mindful of that. Cool, guys. So with this, I'm pretty much done. This is what I intended to cover today. Any questions, anything which you want to ask, guys, I'm always happy to take that. So any questions, please let me know. So, I mean, just to nutshell and tell you, so, but again, don't think that this is the only option. Obviously, Plotly is also one of the very advanced packages, which does helps you to, again, plot some fancy graph, right? So that is definitely going to help you on that. But again, as I've said, other Power BI tools, Power BI Tableau, again, is another tools which is helping you to do that job, but those are paid tools, by the way. Definitely, Shubham, you can do that. So spend analysis, you can try taking the reference from this video and try doing some analysis in terms of visual analytics, the graphs. Why not? You can do that. Don't know where to start. So where to start? I would say, Shubham, first of all, you have to get the data. So for that, you can go to Kaggle or any data websites like Data.gov also, it should be fine. Try to get some data, perform some basic EDAs like, the basic analysis, statistical analysis. And then obviously on top of that, you can start building up some graph. So you have the files with you. You can load it on Python like pandas, PD, read, CSV, and whatnot. And then eventually you can eventually try to work on top of the details where I could say, okay, I have the files available with me now. I can talk about how we can use it in terms of technically building up the graphs, right? So yeah, you can do that. Why not? You can do that. So you can download the account statement in a CSV Excel format also, and then you can try doing that. Yes, absolutely, you can do that. So account statement, it gives you an option to download as an Excel file, right? You can do that. Correct. You can do that. So likewise, you can put up some categories. Like I think it gives you have to manually make up some data there. So put some categories there, like online shoppings or say some other things like eateries or something like that. So you can put some categories. Try to put some analysis there, categorical to numerical. So like box plots, volume plot. So you can put some categories, as I've said, Shubham. So for each of these transactions, you can manually enter a new column, put a data set where you would say the category, which it says, suppose this transaction is for bank withdrawal, or it's for your personal purchase, or say movies, or maybe entertainment, or maybe you can put a category as a fooding, or travel. So put some broad categories which you want to analyze basically, because that is not there in the raw data. So you have to put that spend categories for which you can perform some analysis. So it totally depends on what kind of data you want to analyze, because in this you won't be having the labels by default, so you'll have to add that. So you can probably edit the data. So same Excel file, it'll take some bit of effort, like about an hour of effort, but for each transaction you can add the labels, and then you can add then you can start analyzing your data. Okay. Cool. Okay, I think I did answer your question. Thank you so much, guys. It was a pleasure. Okay, I think one more question from Shubham. Please do let me know. Yes. Yeah, sure, you can do that. And adding projects input or adding projects to a resume or portfolio always helps. Okay, that's a good project, yoga pose detection. Yeah, that's a good project. Yes, you can do that. Multiple images also is absolutely fine. So suppose if you have multiple classes, so you can define all of them in different folders, and then you can train the model. You can do that. Yes. So multiple images is also fine. In fact, it'll help you to give more granularity to your graph, to your model. Yes, you can do that. Yes, absolutely, you can do that. Yeah, that's completely possible. Yeah, Shubham. Yes, you can do that. So that is more like image classification problem, I would say. So like getting the images and then predicting it on the real front. So yes, that's a good project. Cool. I think that was a good discussion. I think these all any projects is anyway in fact fine, Shubham. So don't worry too much about that. So wherever you are using some sort of data and doing some sort of analysis, it's not about building up any fancy model. Trust me, it's about getting onto the ground and doing the work. Okay, that is more important. So for me, definitely. Yes, I'm always available. Don't worry on that. You can reach out to me on LinkedIn also. That's also fine. We can talk there as well. Okay. एक बार आप resend कर दो. I think I might have overlooked that. Do resend that invite, so it might have gone in the backlog. I'll check that. Okay. Cool. Chalo. Okay. Cool, guys. Thank you so much. It was wonderful interacting with you. Looking forward to talk to you again the next day. So we will talk about another topic. So we'll meet on Wednesday post probably. Thank you so much, guys. See you the next day. Bye bye.